Today's lesson is on percents. What's our objective, class? Get ready?
Percent.
Percents. Why do we care about percents? Why is it important? Why does it matter? So on the volleyball team, we actually take statistics. We record how the girls perform in games. So how does that relate to percents? Our last game against Spectrum, I recorded that our team had 33 passing attempts. That's when you bump the ball. So the team, they serve it over and you do a bump. So I had to record 33 passes were made. 14 of them were good. What percentage is that? How did we do? You know, like a C grade, a D grade? How well was that? So we figured out how to take that fraction and turn it into a percent. That's what we're going to do today. Turns out that's 42% of our passes were good. So we got pretty much like an F, right? So not great. We had 9 of our 33 passes, which is 27%, were over the net. Now, while you're thinking that might be good, that's not what we wanted. We wanted to pass it up to our teammates so we could get a set and then spike it over. That's what we want. And then we had 30% of our passes, when we bumped it, it went zing, and it was like so bad, like no one else could touch it after that. So we call that a pass error. So we use these percents in sports to improve our team and find out where are we weakest at, or how weak are we, so how can we bring our scores better? And a winning team is going to have a higher percentage of passing, right? So we're going to talk about percents and how to take fractions and make percents and what it means. So here's a graphic. You've got 25%, 50%, 75%, 100%. Percent means per 100. What does percent mean? Get ready?
Per 100.
Per 100. So if I took 50%, I could write it 50 per 100, and then the percent sign goes away. And then I could reduce that. 50, I could factor out a 10, divide out a 10, that'd give me 5 over 10, right? The shortcut is to go zing, zing. Oh, I can reduce that again. That'd be 1/2, right? So, but that wasn't the question. The question said write it as per 100. I just wanted to kind of go forward and reduce it. 5%, 5 over 100, 5 per 100. And I can leave it like that because it said per 100. But now we're going to reduce. So 1% would be 1 per 100. I can't reduce that. 10% would be 10 per 100. I can reduce that. I can factor out or divide out a 10. Divide out a 10 gives me 1 on top and 10 on the bottom. It's reduced. 100% is 100 per 100, which is 1. It's like 1 whole. Picture that. So find an equivalent fraction with a denominator of 100. An equivalent fraction means 1/4 could be the same as this fraction, but I need 100 in the bottom. So I could look at my denominators and think, what would I do to the 4 to turn it into 100? And we're always going to multiply. So I would times it by, what number would that be? Get ready?
25.
25. If I do it to the bottom number, to keep an equivalent fraction, I'm really going to multiply by 1. So 25 over 25. I have to do it to the top. And I get 1 times 25 or 25. So that's an equivalent fraction, denominator of 100. I leave it like that. So write a fraction as a percent when the denominator is a multiple of 100. Use the equation, the equivalent fraction method. 4 is a multiple of 100. So I can times it by the same number, 25, 25. What would my numerator be, you think? You ready?
75.
75. How would I get 100 on here? What would I times the 5 by, think? You ready?
20.
20. So I'm also going to times the top by 20. My numerator becomes, you ready?
60.
Oh, you guys know this. We're skipping that one because you guys got this really good. What if the denominator is not a multiple of 100? So I can't times 3 by a perfect whole number to get 100. So here's the method. I want you to really listen here. And I see so many of you in learning positions, slant. Thank you. Your eyes are watching. You're sitting up. You're leaning in. Thank you. We're going to take the denominator. Ding, ding, ding. I have students that are still reversing these. The denominator divides into the numerator. Denominator divides into the numerator. What goes into the numerator? Get ready?
Denominator.
Denominator. So 3 divides into 1. Well, it won't fit. So that's when we have to add in a decimal. Right? So we're gonna go like this. 3 goes into 1, it won't. 3 goes into 10, it will. 3 times 3 is 9. We subtract, we get a 1, and we're gonna bring down our 0. 3 goes into 10 how many times? 3 times. 3 times 3 is 9. We subtract, we get a 1. Wait a minute. Wait a minute. Every time? Holy moly, I'm gonna get tired of writing all these 3's, but it's gonna be that way every time. So we have a non-terminating decimal. It repeats forever. What was the question? Write it as a percent. So for my percent, because I know it's all the same number, all I need are 2 digits. So I'm gonna back up and just do 2 digits. I'm gonna back up to where I have a remainder, and I write my remainder. This is the key part. This is the new stuff. This remainder is important. It becomes a fractional remainder. This becomes the numerator. The divisor becomes the denominator. Your remainder becomes your numerator. Your divisor becomes your denominator. And how do I write my answer? Well, we're talking percents, right? So right now I have 33.33. That doesn't make no sense, but I'm going to times it by 100 to turn it into a percent. So I'm going to go and move it there. I get rid of my marks, and I get 33 and 1/3%. So 1/3, the equivalent percent is 33 and 1/3%. Jasmine.
It's not a question, but it was like, I know a way that helps me remember which is the divisor and which one's the,
Okay.
yeah. I like look into my weird future brain and I have a table set up like as the division thing, and I switch between the two, and I ask myself which one's the lower number, and that goes into the thing because it can't be
It should
anything
be
greater
lower.
than 1.
Yeah. If you did this right, this number has to be less than this. Otherwise, you did something wrong right here. Okay, very good. Let's do one more for practice. Tomorrow's bell ringer will be one of these. All right, 5/6. So we're going to long divide. 6 goes into 5. We're going to add in our zeros. Move our decimal up. 6 will go into 50 how many times? Think. Get ready?
8.
8 times 6 is 48. Subtract, we get a 2. We're going to bring down a 0. 6 goes into 20 how many times? Get ready?
3.
3 times 6 is 18. We subtract, we get a 2. We're going to bring down another 0. We already did this one, so it should be 3 again. 18. Subtract. Oh. Okay, 20, 20, 20. I now have established a pattern. I know it's going to be 3, 3, 3, 3, 3, 3, 3. So I'm going to do my trick. I only need 2 digits. I'm going to back up. Take my remainder was 2. Where does the remainder go? I need help from Bo. Where's my 2 go?
It goes up top, and the 6 goes underneath.
6 goes underneath. I've got a fraction, but is it ready to, is that my final answer?
No.
Lexi's nodding no. I'm going to reduce it. So I'm going to say 83 and 1/3, and I'm just going to move it over in one step and say percent, because I times it by 100%, turn it into a percent. Give me a nod if that makes sense. Okay? If you were really listening, this part is the most important part. That's where students make mistakes. So get that remainder up on top. Right there. Okay, let's do.
This is Boone.
Yes.
Preston Nelson is checking out.
Okay, thank you. Okay, you know what tonight's homework is? Okay. Raised percent is a reduced fraction, so 4% means 4 per 100. What does 4% mean? Get ready?
4 per 100.
4 per 100, then we're going to reduce. So I'm going to divide out of 4, divide out of 4. That would give me a 1 on top and a 25 on the bottom. Reduced. 40%, 40 per 100. Hey, let's just do this. That's like dividing a 10 off the top and the bottom. Gives me 4/10. They're both even. I could cut it in half. What's my reduced fraction thing? Okay, ready?
2/5.
2/5. You guys are good. Ooh, what if it's a mixed number? Hey, this is when I really want you to listen. We're going to have another one of these coming up. We have to first write the percent as a per 100. What do I write it as, class? Get ready?
Per 100.
Per 100. This is important. Everyone's looking. Colin's watching. I know he's listening. Ethan's watching. Thank you. Then change your mixed number into an improper fraction, because that's kind of a pain to work with, right? Change it into an improper fraction. What do we change it to? Get ready?
Improper fraction.
Improper. And I know some of you forgot how to do this because it's been a whole year. Take your denominator, times it by the whole number part, add it to your numerator. 3 times 33 is 99, plus 1 is 100. Then keep your denominator in place. Big division line, there's your big division line, and then rewrite your 100. Ooh, it still doesn't look great, but what if I did this? Change your whole number on the bottom to a fraction. Fraction divided by fraction. Oh, you remember these.
dividing.
Fraction by fraction, you're gonna copy, sorry, we're like this, right? Copy dot flip. Copy the top, change the division to a dot, and the bottom we flip. Copy dot flip. What do we do, class? Get ready?
Copy dot flip.
Copy dot flip. Copy the top, division to a dot, bottom flip. Copy dot flip. Oh, look at this. 1/3. So 33 1/3% takes a few steps. I showed my work. I wrote it out. Don't try to do it in your mind, because you're in more advanced math now. You have to write more steps now because you're doing harder math. Write your steps. You're gonna get 1/3.
But what if I already memorized what that is?
All right. Okay, we're gonna go on to page 75 for the practice set. Take a 20-second stand-up break, and I'll write your practice problems on the board.